So I'll have to go back and record what I skipped, but I'll do that. Okay, so I'm recording, and these recordings are going to be put on YouTube, and then I'll give you the link, because YouTube is, except it will be unlisted, okay, which means the only people who can get to it are people with the links. Okay, so now that's these two. These are the two major kinds of, I mean, these are already introductions to set builder and interval notation, but then we come on down, down to other possibilities. For instance, all the numbers between -6 and 13, including -6, but excluding 13. I keep hearing a ding. Do you hear a ding? And I wonder if somebody isn't trying to get in. I hope they're not in the waiting room.
Yeah, it looks like something's in loading.
Is someone in the waiting room?
Yes.
Okay, I'm going to increase the size of my screen and look for where it says somebody is in the waiting room. You see, I just don't see it. I just don't see it. And I'm looking at all the participants, and there's nothing that says waiting room. So I'm going to assume everyone's in here who needs to be in here. Okay, now where was I? Yeah, in this one, we're including -6, but we're excluding 13, which means x can equal -6, but x cannot equal 13. This is the way we would say that in interval notation, and this is the way we would say that in set builder notation. Namely, the set of all numbers, that's what the braces mean, such that x equals all real numbers, such that they obey this rule, which is that -6 is less than or equal to x, but is strictly less than 13 because it's not allowed to equal 13. And the way we would say that in this drawing would be that I would get rid of this and put a parenthesis here at 13, which would say the same thing. Okay, that we're talking about all the numbers between -6 and 13, but not -6, but yes, -6 and not 13. And then we reverse that, where we exclude -6, the left endpoint, and we include 13, which is the right endpoint. And so now you have the parenthesis around the unincluded endpoint and a bracket around the included endpoint if you're doing interval notation. If you're doing set builder notation, then you have braces, you have X, you have the vertical bar, and you have -6 is strictly less than X, but not equal to X, because it's been excluded. On the other hand, X can equal or, or is less than, excuse me, gotta have a drink. Is less than or equal to 13. Now, this is a pretty good example to give you the basics of how to write interval notation, how to write set builder notation. You've done set interval notation before, but whether you've really looked seriously at set builder notation depends on where you went to school. Okay, now we're going to talk about this. What happens when there is not an endpoint? Oh dear. Okay. Well, let me get rid of this. Here we're talking about all numbers starting at -4 and going to the right forever. Now, I just went ahead and assumed x could equal -4 to make life a little bit easier, but let's get a picture of what I was talking about. The numbers that x can equal start at -4. And I should have said or can equal -4. Again, just my assumption. So x can equal all these numbers, decimals, fractions, going on forever to the right. Well, the symbol that we used for forever to the right is positive infinity. That is just the infinity sign. So our x's starting at -4 can go all the way to infinity. A billion, 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 trillion, zillion. And it just keeps going. So we have to have a way to say this that doesn't include zillion. And here it is. Interval notation gives us just the perfect setup to say exactly what's happening on the number line, which is that x starts at -4, goes forever to the right, and the only thing out at forever to the right is infinity. So I make it infinity, and then I make a parenthesis because there's no way to measure infinity. There is no exact number that infinity is. So you can't say that x equals it. You have to put a parenthesis. Brackets mean equal, so you don't put a bracket, you put a parenthesis around infinity or negative infinity, because they're just symbols. Now, on the other hand, there's set builder notation, which is a little more down to earth. And what it says is what this says. Oops, this one right here. That x starts at -4 and goes to the right forever. Well, here we have x and an arrow pointed to the right and an equal sign because x can equal -4. But it's just going to keep going. This is the way that you say x is going to start at -4 and just be everything to the right of -4. In fact, you could even write this in words. X is everything to the right of -4. Now, if we want to say the opposite, and that is all the numbers starting at 17 and going left forever. What that says, if you have a graph of it or a picture, whoop, erase. Yes, okay. Is that x is going to start here at 17. And I'm going to assume it equals. And then it's going to go forever, forever, forever to the left. It's never going to stop, not ever, ever, ever. And the symbol for that is negative infinity. So zoom, x can equal all these numbers. And I've never been able to draw a straight line. So that would be kind of a picture of the situation, and interval notation looks just like that. Here you're starting at 17 on the right and going to the left forever, and being sure to use a parenthesis around an infinity sign, even when it's negative infinity. Over here, you have x is to the left of or equal to 17. So this is actually stated as you would write it from left to right. X is to the left of 17 or equal to it. Now we're over at 8:45, right? Is that right? 7:30 to 8:45. So I cannot drag your suffering on more than this. So what we covered today was linear functions. And then we did a review of interval notation so that Wednesday we can start talking about domain and range, and decimal and function arithmetic, and then the ultimate function arithmetic, which is just one problem, I think, or two, maybe three, real fast. I mean, all we're going to do here in the lecture is one of them. But yeah, it's called the difference quotient. And it's a very big deal in business and economics and finance, which to me are all economics, but I know to business majors they're different. But until then, why don't I end the class and say, if you've got any questions about this, stay behind and let me know. And if you want to just go ahead and leave now, feel free to do that. And yeah, let's do it that way. If you have any questions, ask. If you don't have questions, go ahead and leave and take on the first two sets of homework that you're going to do. That's right there in my math lab. And be sure to get in my math lab. Remember, it's being paid out of your tuition and you get a 40% discount. So, yeah, there are two links in the syllabus. The first one says how to register, or something like how to register in my math lab. The second one says registration number for my math lab. Use both of those to let you register in my math lab and get to work. Talk to you later. Bye-bye, or turn your mic back on and ask questions. Thanks a lot.
Thank you.
Thank you.
You have a wonderful day.
Thank you.
Thank you. I appreciate it. Bye. Remember Granny and the Beverly Hillbillies, if you've ever watched those, any of those reruns. No. Bye. Y'all come back now here.
Professor,
Yes, who's this?
this is Carla.
Hi, Carla.
Hi. I wanted to ask, I have been out of school for 13 years, so I'm starting all over. What is some of the best tools out there that I can use to really refresh on all of this?
Um, it might be a good idea, since this is really the first day that anybody thinks of as the semester, to take foundations of algebra. It might be a good idea to start there because that would take Algebra 1 and Algebra 2 combined and
Okay.
go over those concepts, and then take College Algebra in the spring. That might be a better way to do it. In fact, I'm pretty sure it would be a better way to do that. If you go to the syllabus, my syllabus, don't just drop it. Don't drop this class yet. But instead, go to the syllabus and look at contact information, and you'll see the contact information for Michelle Batchelor.
Okay.
She's our math advisor, and it will be easier for her to get you into a class, a Foundations of Algebra class. If you're still registered in one class, then it's so much easier for her to get you registered in another, whereas she says she has more difficulty if you drop.
Okay.
So don't drop yet, talk to her first.
Okay.
And she's really nice.
All right. Thank you.
Thank you and good luck.
Thanks.
Dusty, Jessica, do you have a question? Dusty, it's only you. Oh, you're muted. I can't hear you. Well, I'm going to turn off recording. Hello? Yeah.